My name is Vlad Mihalcea, and today I want to talk to you about JSON processing in database systems. Now, a little bit about myself. My name is Vlad Mihalcea. For the Romanian who are participating, it's fairly easy. For the people who are from outside, not from Romania, it looks very frightening when they see my last name, but it's not. It's not very difficult. It's Mihalcea. And I'm an independent consultant. I run my own company nowadays. I'm mostly blogging. This is my blog. Exactly like I said, I'm probably on Twitter and LinkedIn a little bit too much. Maybe you can find me on Twitter, and nowadays I'm quite active even on LinkedIn. This is my GitHub account, and this presentation and some parts of it are also inspired by my book that I wrote called High Performance Java Persistence. Now, before I'm going to present you about JSONs, because I was running a poll in the beginning of this before the introduction, and I was asking you what database systems are you using, and most of the persons who replied were using Oracle and PostgreSQL. Someone was also using MySQL or MariaDB. And the thing is that all these databases now support JSON column types. So it's not a feature that's limited to just one database. All of them have it. But then why use it? Because a relational database, you are going to mostly use it to model data in a relational fashion. And that's, as a rule of thumb, that's the right thing to do. That's the first, that's, let's say, the most and the best way to model the data when you're using a relational database. However, there are times when you can benefit from something like a JSON column type, which previously, let's say like 10 years ago, was only available in NoSQL databases, but nowadays you have it. So why you would even use it? For instance, one use case where it actually fits in very well is if you want to store some audit logging information, and you will have something like, for instance, you have a book table in your database that you want to audit. And for every such table, you have, for every table that you want to audit, you will have a book audit log table. This is a separate table that's going to store the old data and the new data whenever you are doing some DML statement like insert, update, or delete. And you can also capture additional information like when the statement was executed and who actually executed that particular statement. And as you can see here, I'm using JSON for the old and the new raw data. For every time I'm going to change it, I want to store and this JSON object. And the advantage of using JSON is that it gives me the flexibility of disregarding how the schema is going to change, because I can, in time, the book table is going to change. I'm going to add new columns. Maybe I'm going to rename or to delete columns which are no longer relevant for my business. And I don't have to change this book audit log because because JSON is non-structured, I can store whatever I want there, whatever the state was at the time the DML statement was executed. And that's one great advantage. So for instance, if you're using Postgres, that's how you do it. You would have a trigger, and that trigger would write the audit logging data. But actually, I can even show you. I have test cases for various database systems. We can take one. This one is for PostgreSQL. And this is the table. We're creating the book audit log table that has the book ID, which is associated to the identifier in the book table, the old raw data, the new raw data, the DML type, which is an enumeration in our case, that's restricted to only these types, because we're basically only inserting, updating, and deleting records based on these statements. We're going to capture the old and the new data, and the time when we execute this statement, who did this, who executed this statement, and the transactions timestamp, because we can have multiple statements being executed and want to have them, to have an information to group them by something, to aggregate them and see exactly what actually we executed for the same transaction. And if this is PostgreSQL, you can actually create a single function, and this function can operate like this. So basically, you can inspect what statement you are executing. And for instance, if we're executing an insert, we're always going to insert into book audit log, because this is an append only table. So we're going to insert into it. And here you can see that the new raw data is going to capture the new state of the record. And if I want to do an update, I'm going to capture the new state in the new raw data column and the old state, the one before executing the update. And I'm going to store that one as well. And when I'm doing a delete, I'm going to capture, of course, the old data as if it were before running the delete. And then, of course, for the new raw data, I have to insert a null there, because the record is no longer reference, or you cannot no longer reference it. And we can see how this one actually works in practice. So this is a test case. I'm going to run it. It's an integration test. I'm going to run it in debug mode, and then we can just go to the database and see exactly how this one works. And that's why I wanted to start with this one, because this shows you why you'd want to use it. Because if you don't have the context, then probably you would wonder why exactly I'm actually learning these new features. And here is PostgreSQL. I'm going to connect to it. Let me refresh the database. And let's inspect what tables we have there. Well, okay, you have a book table. Here is empty, and a book audit table, which is also empty because I don't have anything at the moment in the database. And the way I'm going to insert who's doing this change, I'm just using here a variable. This is a session variable that's just going to be inserted here. So here, look what happens. So I'm going to insert, behind the scenes, this one is using JPA and Java and Hibernate, but you can use it with anything because this is a trigger and it works. You can use JDBC, you can use even a different programming language, even the command line, and it will still work. So basically whenever I'm doing this persist, I'm going to just insert a new book. So look what happens when that happens. So this one was executed. We go here. We're going to refresh and we get to see the new book. So this is the book that I created. And if I'm going to refresh the audit log, I'm going to see that indeed there was no old raw data, but there is this new raw data. And you can see this JSON that captures exactly the state of the record that I've just inserted. And it was an insert statement when it was executed, and it was executed by me. So I know exactly who's doing things in the database. And then I can just get to this book and I can update. I'm going to change the price. And when this statement is going to be executed, I can see here, look, the price was $39.90. This one is in cents. And when I'm refreshing it, now the price has changed. And if I'm going to navigate to the book audit log and I'm going to refresh it, I'm going to see two records now. The second one captures the old raw data and the new raw data. You can see that the price changes from one to the other. And this was because of the update and when it was executed. And of course, you can do the same when you are going to basically remove the record. You are going to capture that operation as well. And of course, the record is not going to be referenced anymore. It's deleted. But it's not, it's still trackable in the audit log. That's basically the point why we even had this. And we see here that was the last state of the record before I deleted it. So I captured everything that happened against this record. And the beauty of using JSON is that even in the future, I don't have to update all my triggers. I don't have to update everything that's related to audit log every time, and remember whenever I'm doing a change to the book table to remember to go and update the triggers and audit log tables. Because why this is an advantage? If this table grows very large, it's probably going to take some time to apply those modifications, and the larger the table, probably the more it will take to apply that change. And of course, I cannot drop columns, so because they will have to retain the old state. So basically, this is why you'd want to use it. And now you have all sorts of options depending on what database you are using. For instance, if you're using Oracle, most of you have opted for this. Since version 12, Oracle has added support for JSON. And you have two options. You can use a varchar, you can store it as a string, or you can store it in binary fashion using a lob column type, like a blob or clop, for instance. And basically here, if you're using varchar, you can define how you'd want to store it. You have one option to store it in a varchar, let's say maximum 4,000 characters, there, 4,000 bytes. And as long as your JSON is not large and it can fit in that column, that would be great, because the advantage is that if the record can fit in in 4,000 bytes, then it can stay in the buffer pool, it can stay in the page itself. Otherwise, if it's larger and you need to give more, you need to store larger objects, the thing is that in that case, it is going to be stored in a different location to avoid putting pressure on the buffer pool. And you even have an option, as you can see here, you have an option to check at the moment you are doing the insert, at the moment you are doing the update. You can have this is like a check constraint here, where you are going to validate whether the property here, because you are storing it as in a string column, you could store there anything you want theoretically, but this check is going to validate and make sure that that particular string is indeed a JSON. So you are storing a valid JSON, not just any string value. So that's nice, because you are going to validate and make sure that you're basically, with this, you are making sure that your inserts are consistent. You are validating consistency in ACID with this check. And the same, you can do it in even if you're doing a blob, and you have this option to store it as a cache, to place the lob pages in the buffer cache to speed up the operation, the reads and the write. And inside, when you have this JSON, of course, the JSON is a nested structure. It's unlike the relational database. Inside you have, it's more like a graph or more like a tree, because you have properties, and one property can be an array, and inside you can have JSON, and you can nest JSON in JSON in JSON. And for this reason, being hierarchical, you have this path expression where you can go inside and tell exactly what you want to reference inside that JSON. That's the root. And then you can, this one would be one property, this one would probably match an array here. Here you can go inside the array and tell the first element in the array, I want the date for that object, or the reviewer of all the elements in the array. So you can use this path expression to locate, and even with using this question mark here, you can actually filter and only get the elements inside that match this filtering criteria you're giving. And in Oracle, you also have this option to define whether you want a strict or, on, let's say, less strict mode when you're operating with JSON. What would be strict? It means that, as you can see on the left side, you have to make sure that your JSON is constructing in such a way that it's let's say the in a proper form. Like, for instance, here I'm only using double quotes, but if I'm using the LUKS or non-strict mode, I can just mix double quotes using with single quotes. Or here, if you're using a boolean, it must be true, false, or null. But here, if it's a non-lax, I can just play with case. It doesn't have to be case sensitive. Or here I can have extra commas at the end, or the numbers can start with 0, or I can just add the minus or plus sign here. So all sort of variations. So depending on whether you want to validate so that your JSON is strict. Why would you want to do that? Maybe when you consume this JSON, when you send it to the application, maybe the framework that reads and wants to interpret that JSON, maybe it uses this strict mode. It requires this strict mode. So you want to make sure that the moment when you write it, the data that's being written and it's durable now, you want to make sure that it's also correct. And how you can do that? You can just specify the strict mode when you're doing this check constraint here, and you say that it's JSON, and also it's obeying, it's following the strict mode. And every such JSON column type also have it gives you the option of calling this method. So even if it's just a varchar column, basically the database allows you to call this method here, giving you the type of the element that you are validating there. What's exactly, so because a JSON can have even an element inside the JSON, can be a string, a number, boolean, array, or even an object itself. The size, whether it's a string, the number representation of it, double representation, date, timestamp, and so and so. And you even have methods to give it the length of the string, the upper, lower, the boundaries of the, or to make it uppercase, lowercase, or floor ceiling to round it, around the number accordingly. And many databases like Oracle are using basically these methods, which are from the standard. So before, um, let's say like 10 years ago, the SQL standard didn't have support for JSON, but in SQL 2016, JSON was added to the was introduced into the standard, into the SQL standard, and these are the methods which database systems should support. So this one, JSON exists, basically just evaluates the path, that JSON path expression I gave you, against the JSON object, and tells whether that one returns true or false. This JSON value, usually you'd use this one to just extract a scalar value, like a boolean, a number, or a string out of that JSON. This one, JSON query, allows you to evaluate against the JSON and get this time not a scalar value, but an array or another JSON object that was nested inside the JSON object that you wanted to query against. And this one is, we're going to see, is very nice. It allows you to, from a JSON object, to get a virtual database that you're constructing. And once you get the virtual database table, you can do whatever you want with it, because then you can use any SQL feature available in your database to aggregate it, window function, common table expression, pivot, whatever you want, you can just apply on it, because otherwise you couldn't do it on JSON, because that's not relational. So how can you use it? For instance, for JSON exists, you can also vary how you handle errors. For instance, if there are any errors, by default it just returns false in this case, but you can trigger an error, or you can just return true. So you can customize parsing errors, how it would behave when a parsing error occurs. So here, what would you use JSON exist? It makes sense to use it, for instance, for a filtering criteria. Like, for instance, I want to get a projection from the book, but only if, for instance, in this properties JSON object, I have at least one review. So how would I do that? Inside these reviews is an array. And here I'm going to tell it that go inside that JSON object, check the reviews, which has to be an array, check the size, and only if there is at least one element there, then that's going to match this criteria that I gave. So only return the books that have been reviewed, have at least one reviews. So here you can see that this is my JSON object. It has a title, an author, a publisher, a price, and it has a reviews array containing multiple reviews from people that reviewed this particular book. And here I can see that indeed it matches, so I get the projection, so it validated. So that's what JSON exist is going to be useful for. And you can use it, of course, even in the select clause, and then in the select clause, for instance, you can use it in a case expression to make sure that only when this, if this record was written by this author, then match, and then you can decide what you want to return from this record. And JSON value, as I told you, this one evaluates and gives you scalar values from inside that JSON. And for instance, you can use it to return. Here I'm returning, I'm not just validating, I'm actually returning the price, and I'm telling that I don't want it as a string, I want it as a number. So as you can see, even if I validate in the path expression, I can basically use these functions so to add an extra cast. Of course, you can also do a cast here, but it's much more convenient to do it inside the expression itself. And here in the where clause, you can see that I'm not only using for the projection, but also for the filtering criteria, because here I'm matching the title attribute of this JSON object. And if it matches this value, only then I want the price to read the price. As you can see here, it matched this record and it gives me the price. And you can customize here how you want this data to be returned. If I want this number to be returned, and as you can see here, I'm actually telling the format of the number, and also you can give, you can specify what will happen if this one cannot be parsed as a number. Maybe here someone just wrote a value that's not even parsable as a number, and in that case, I want to tell that I just don't want to return some empty value. I just want an error to be triggered and to get an error result set. I don't want to get, let's just say, a dummy value out of it. And JSON query gives you the option to select from a JSON. You are going to go inside the structure and select arrays or JSON objects from it. And basically, you have the option of, with the wrapper, you have the option of either wrapping it on avoid wrapping the result set. And by default, this is what you're going to do. By default, you're not going to wrap it. So you're going to just match what you're going to see here, and you're going to return it exactly like it was found there. With the wrapper, you're always going to wrap the object in a JSON array. And with conditional wrapper, if the object that's matched is already wrapped, you're not going to wrap it. Otherwise, you are going to wrap the result set. To have, let's say, why would you want to do that? For to have a consistent result set. So here I'm going to get, you can use this one to get the arrays of reviews from that JSON object. For instance, I had this reviews array, which each element was another JSON. So I can select it using this JSON query. So you can get the result for that. And there are other functions which you have available. This one, merge patch here, allows you to apply some modification, insert, update, and delete inside a JSON object. And here how you can use it. For instance, if you don't use the JSON merge patch, how you'd change that JSON object. Whenever you have, even if you have a very small change, just one attribute, you will have to just give the entire JSON and send it to the update. But if you don't, if that JSON is fairly large, you don't just want to pass a lot of data back and forth from the database or to the database just to apply the modification. So basically you're going to do this patch. This is exactly like in HTTP, how you can post an entire object, JSON object that you're sending to on REST, or you can just use patch or put and then just apply even and merge, apply just one slight modification. And here, for instance, I'm going to tell that I only want to change just the language attribute and change it to English. But if this one is, there's no language attribute there located, it's just going to insert a new attribute. So if this is the object that we had, when I'm executing this statement, I'm just going to inject a new attribute without having to send the entire object. I'm just going to do it just for this attribute alone. And you can do the same when you want to update it. You can update an attribute, but this time this attribute already has a value, so I want to change that value. So as you can see, it already had an attribute called with the name price, and it had a value, and I just don't want to send the entire JSON just to update the column, because basically that's how you do it with all the other columns. If you want to change it, you just override the old value with the new value. But here, when we don't want to override the entire JSON, just bits of it, just one element, just one attribute. And that's exactly what I'm going to do, and it's going to change exactly that. That's, of course, it's much more efficient to do that instead of updating, changing the entire column value. And again, you can do the same, even if you want to just remove one attribute because you don't want it anymore. I'm just going to delete this publisher attribute because it's no longer needed. And one function, which actually this is one of the best or the most flexible of all, this JSON table allows you to, okay, so we had this JSON column. We stored there a lot of information, but now, as you can see, I'm quite limited when it comes to how I want to get the data. So yes, I can extract some data. I can extract even JSON objects, but still SQL is much more powerful than that, but it's only powerful as long as your data is structured as a table in SQL. That's how all the SQL features they were meant to be to execute against relational database structures. And JSON table gives you exactly that, because you can now map your JSON object. You can now map not just the entire object, but even you can match, let's say, a path expression, and whatever that path expression is going to return, you can match and return it as a relational database table where you define the column names, their types, and what exactly in these objects you are going to map on this column value. Like here, the reviewer inside these JSON objects that were contained in the reviews array, the reviewer attribute, I want to, on the reviewer column, the reviewer on that one, the date and the rating. And when I'm doing that, as you can see here, so this is what is it was going to match. So inside that properties, I was having this reviews array, and each element contains another JSON object, because JSON is a tree-like structure, and I'm going to store there everything hierarchically. So now I'm just going inside, evaluating these reviews using, as you can see, this is the root. So from the root, I'm going to the reviews array, and because I have this star inside the square brackets, I'm just going to tell that I want every element, match me every element that you find in that review array, and then map on this virtual table here. These are the columns, and then for every, this is going to be for the first object is going to be mapped to this to this element, then to this other element, and so and so. And this one is gives you a lot of flexibility. Doing that gives you a lot of flexibility, because now once you get this result set, you can use derived tables, and you can transform this to whatever you want. You can aggregate, you can build reports which are much more advanced and require you to use window functions or something that basically you didn't have if it was structured as JSON. So just because you stored it in JSON, it doesn't mean that it has to stay in JSON like forever. Okay, you had the flexibility of storing the unstructured data, but then at query time, you can retransform it and do and benefit from all this, all the power that SQL has added support for all these times. And you have all sorts of other features that are available. For instance, you have an onEmpty clause giving you what you want to do. For instance, when a given path expression doesn't evaluate or it doesn't find something there, and you can define here what you want to return. Do you want to return null, for instance, for JSON value? Do you want to throw an exception because you expect it to have something there? Like for instance, you want it for a book, you wanted to, you were expecting there to have a price. But what if you don't have that attribute, or that one is empty? What are you going to do? Just returning some zero value doesn't make any sense. I don't want to send or stuff that's free, so better throw an error, and you can do that using error on empty, and the default is just a default value that you might have there, and the default value according to the JSON semantics. And for instance, here I'm just going to reference in JSON value some property which I don't have, and if you can see here, it just returns null here, but that's not what I want. I want to use error on empty, and if I'm using that and I'm referencing a property which is not referenced in this JSON object, now I'm going to get this exception. And as you can see, you have a lot of flexibility, even for JSON. But now, okay, so you have the option of getting scalar values, arrays. You can use it for matching to define to get a true or false result, to evaluate an expression, or to extract some data. But of course, if you have a lot of data in your table and you don't have any index for this JSON function that you're calling, then you are going to scan the entire table, and the larger the table, the more time it's going to take. And of course, you don't want to wait a lot of time just to execute those queries. So you want to use some indexes. But what type of indexes you could use? Well, really, it depends on what exactly you want to. It really depends on what are the operations that you are executing using this JSON column, and also what you're going to return, or what you're going to what's the type of data that it has to be indexed. Because for instance, you have the option, like most of the time when you have a relational database and you're indexing a given column, if let's say it's a varchar, or maybe it's a numerical value there, or a date, a timestamp, most of the times you're using a B+3, a balanced binary tree to index that value. But the B+3 is very useful when you have data that has high selectivity. So you're basically interested in filtering or matching a very small subset of data among all the records that you have there in that database table. So you want to pinpoint, to find the needle in the haystack, and that's exactly what the B3 is useful for. But it requires you to have a nice distribution of value. So the better the more they are scattered and they are stored in the B+3, the faster you're going to find it. However, if it has some values, like for instance, that only evaluate to a very limited number of values, like when you have booleans, so you want to match a condition, whether something exists or not, or maybe you have reviews or you don't have reviews, that type of query returns true or false, and you would use that in the where clause to actually to match or not to match a given record. And for those types of expressions, a bitmap index makes more sense than a B+3. So you have the option of using a bitmap index for those types of expressions. So here you have to think how we are going to use how you are going to access the data. And once you know that, you are going to also know exactly what type of index is going to fit and is going to give you the best performance when you are going to use it. So you have to know exactly. But basically, when you add an index, you just don't add it just blindly there. You usually add it for a purpose. You have a purpose. You want to optimize a given operation, and you know exactly what type of operation you have there, and for a type of query you want to add that index for. And of course, if you want to just query against some text-based, maybe you have a string there inside the JSON and you want to evaluate it there to find something in that string value, then a full text search, or a search index, makes a lot of sense. In this case, this is an inverted index. It's not like a B3. Basic, this one takes the string, tokenizes it, and for every let's say tokens, is going to tell exactly what documents are going to be if a given document contains that token or not. So this is an inverted index. It's very different than a B+3. So this is how you'd create it. So we had the same book table we used before, and there we had that properties JSON. And let's say that I want here to I have this type of queries here where I'm just going to have a projection, but I want to evaluate this title attribute. That would make sense in a way, because there are many queries where I am interested in finding some books, but the user is searching by the title, because the title is quite usually you search by book titles. You're interested in particular titles. So what type of query here would make sense? You can just create a B+3, because the title has good selectivity. Rarely people don't write books with the same name. They want their publications to have something unique in them. Sometimes they match the same title, but usually not. So this title has good selectivity. Makes sense to use a B plus 3, a standard default index. So you create the index exactly like you'd created for a column. The only difference is that now, as you can see, you are not going to stop at the properties there. You are going to tell, okay, properties, but the title attribute inside that properties JSON object. And when you're executing this query, you can see that, okay, indeed it was an index range scan, and this index was actually used, and one record was actually matched. So I didn't use a full table scan on this one. So it worked nicely. But I had to know exactly what type of information I'm going to get out of it and what selectivity it has in order to decide what type of index to add for it. And as I said, if you have if you want to optimize a query, but now it uses JSON exists, and this one returns either true or false. So this one can only return two possible values. And this one doesn't make, it's not a good fit for a B plus 3. And in this case, I'm going to use bitmap. And bitmap is plays well for whenever you have a very limited number of values that you are returning. So you're using this bitmap structure. And I'm going to create this bitmap index. And I'm going to tell that this time this is like a functional index only for this type of expression. So for the JSON exists, for this property, for this path expression, when it evaluates the value, every time. So inside the index is going to store the result of evaluating this expression. So when I'm going to evaluate this one at query time, it can go and use the index, and it's going to be much faster to give me the result. It doesn't have to evaluate it for every record, for every value, for every JSON object at query execution time. And the search index, this one, when you created this time for the entire JSON object there. So you can see I'm creating a search index, a full text search index on this book properties, and declaring that this one should be created for JSON. So it has to parse it as a JSON, because this remember that we were storing these JSONs in varchar or a lob column type. So I want to parse it. When I create the index, I'm telling that parse it as a JSON, so store it, tokenize it as a JSON, and then when I'm going to execute something like JSON value, and there you can give whatever you want this time. You can give the author, you can give the title, you can give the price. Then it's going to use this full text search, and it's going to find the record and give you a response, which most likely is going to be much faster than doing a full text search. So as you can see, you have a lot of flexibility using it. And now you can think of how you'd want to do something like that. So for instance, in this case, what we would want to do. So I have this book and I have these properties, and I would like to get the average rating for this given book, because you see, I have users and they give all sort of reviews. I have their multiple properties, but one of those elements, one of the attributes inside each element in the reviews array contains a rating. So as you know, on Amazon, when you go there, you have 5 stars there, and then it just fills in those stars based on what's the rating for the book that you want to order. And maybe you are interested in books that have more than 4 stars or more than 3.5. So you want to display this information on your site. So in order to get it, of course, you have to execute a query to give that to you. So how you would do that? Well, let's just get here the Oracle JSON test, and let's see exactly. So this is for the JSON table. Basically, we need to use the JSON table for that. So from the JSON object, we need to get the relational database representation of that record. So I'm going to use something like JSON table, but not just to return the table itself. I'm actually going to use that but then I'm going to use a derived table from that one to just calculate the average rating that I was interested in. So basically, this is the query, and this is how we select it. I'm using here in Java the text blocks. Makes a lot of sense for queries when you want to represent queries. We can also run it in the database. This one runs against the Oracle database to give you the result. And let's see what we got from this one. So it's the rating was for this one. Let's see what it was. 467, because I was having, what are the values that I was having here? 5, 5, and 4. So it calculated it for us. But you can just, let's go this time to Oracle. Let's connect to this one. And let me refresh it. So we can go exactly on the database and run the queries, the query itself, to see exactly how it's running. Takes a little bit of time. Hopefully, it will give us. Let's see. So I have the console here. Let's do like that. So let's select to see everything we have from book. So this is, as you can see inside, you have these properties, and it has here even has this reviews attribute. And let's just take the query we had, this one. And basically we're going to, from the book, we're going to JSON table to extract the reviews, and we're interested in mapping the rating. So I want to extract that rating because we want to use, we want to basically to aggregate it. And when I'm running, let me do like that. See if it has parameters. No. And it's calculated and provides us the value that we were interested in. So basically, this is how you'd use it. It's not sure if you use it so far, but actually it's quite useful to use it. I use it, for instance, for audit logging, but you can store it even for other type of unstructured data that you have. Of course, in this case here, you could just store this title, author, publisher, and price in their dedicated columns in the tables itself. It's just for, let's say, for demonstration's sake. But if you have some data that's being provided to you that's not used frequently, or maybe it's some data that, like it was the case for this audit logging in my case, and you want to reconstruct the object structure, the table row structure, exactly like like the record was at the moment that statement was executed. Yeah, you have the option to do that and extract exactly and get a table record exactly like that. All right, so I think that we managed to cover. We don't have enough time. We only have like 1 hour. So luckily we covered for Oracle, which is the database most of you are using it. It was in the poll there. Now, if you have, we have time. If you have questions, you can unmute yourself and ask me any question you want, or you can write on the chat, and then I will have to check the chat. So we have plenty of time. We still have some time to answer some questions. Otherwise, I'm just going to leave Pete to talk to you about microservices.
Scrambling to my microphone. Hang on. Take a break, folks. Irela, you there?
Yes.
Okay.
I am here, but I was hoping that people are coming with the question. I know that if they are writing down, it takes a couple of seconds.
More time, yeah.
Yes.
Sorry, guys. I have a question, if I may.
Sure.
Vlad, thank you for the presentation. This is very useful. And I will move forward with my question, asking you in case of being necessary to perform many interrogations in the document, how would you store it? Would you store it like a JSON column, or would you break it into regular, if I may, columns in Oracle or any other database, and store the values directly in the columns, not in all in one as a JSON file?
Well, I can tell you how we actually did it. So when we were developing at Ovi.com, that's the largest real estate platform in Finland, and we were getting this JSON information from real estate agencies. And of course, the best thing you can do is to just get it, put it into some ETL process. In our case, it was using Spring integration. So we were parsing it and we were storing the relational, of course, in the relational database, because it matches the best the way we're going to query it. So parsing was the best option. However, we also stored the raw structure, the JSON, exactly like they sent it, because during this process, sometimes validation or some problems, or not problem, if they sent us the wrong value, that wrong value would propagate, and it would be it would eventually be displayed the wrong value on the site, and they would tell, oh, what are you displaying there? This is not what I sent you. And then we would just give them the exact, but this is exactly what you sent me, and then they would just go, oh yeah, that's my fault. So we were doing both of them, storing the raw exactly like it was given to us in JSON, and then we also parse it. And most of the time, of course, we were just going to the right columns because they were parsed and stored and much more efficient to index anyway. But yeah, sometimes you need both of them. But most of the time, let's not forget that we're using a relational database, and if you can store in a relational, always go for the relational database. But if there are use cases where you need to use JSONs, luckily nowadays we have nice column store for it. We have indexes for it, so it's better than just store it in a, let's say like before, in a blob there, and then not have any insight into what's inside, not have a way to index it properly or to retransform it. So I think that
okay,
mostly,
I got a point. I got a point. So concluding, if the data needs to be processed, would be better to keep it in relational databases. And but for history purposes, to keep in a JSON column, or maybe, I don't know, external tables or
something like that.
System or something.
Whatever it's flexible to you. Now, I think that it's nice that we have this JSON, because previously how people would do it, they would store the relational database, relational data in a relational database, and just employ a new, like a NoSQL database just for the JSON part. But the more databases you are using, like there are people, like famous people on the internet telling you that, oh, let's do polygon persistence. Well, for us a developer, it's nice. As someone that does operation, that's nightmare, because now you have to do maintenance for all those databases, do backups, monitoring, replication, do upgrades. The more you have, the more you are going to work you are going to do. So if you can just skip not adding other databases and just use one, then it's much easier for you when you're doing operations, because someone has to maintain that system. That system doesn't just magically maintains itself. So I think that if you only want that JSON for some specific use cases, and you can store that also in your database, do it there. Just don't add another database just because you want it to do two JSON columns there. Make sense?
Okay. Thank you very much, Vlad.
You're welcome.
There is a question in chat also. Can you have a look, Vlad, please?
Well, I took a look, but it says, congratulations for the presentation. Very interesting and useful. And that's it.
No. There is
that's what
a
I
question.
see on the chat.
Okay.
Where is it? But that's the only thing I see. It's from Diana. So I only see a single thing.
I'm seeing a question from Amit. We are storing item category in 350 column table, and I am planning to propose to use JSON column for item. year and category for a particular model now. But do you think it makes sense? We are on Oracle 1201. And he's continuing. I mean, we have 4 columns for model, item, year, and category in a 350 column table.
But I don't see why it would be an advantage to just group them and store it there. So probably I would just keep them. So sometimes you have more columns, but that doesn't. It's not really an issue for the database. You only want the projection. You only want to filter. You don't need to filter all of them. You can even use views and just have separate views. So you have 300 columns. Use a view to just select only a subset of columns and operate only on that view if that's an issue. So you cannot focus on what you want because there are too many columns. But I don't think that you would have to go to store it on a JSON for that, because basically from a performance perspective, you might end up with something that will actually perform worse than where you started from. So of course you can try it in a branch and see whether you get acceptable performance out of it. But I think that if you have 300 columns, there's a good chance that you also have a lot of rows in that table anyway. So because it grew over time. So if you plan to do any such changes, do it in a separate branch. Try it and see exactly what's the performance for the queries that you want to execute, and only when you know for sure that the queries that you are executing every day we are going to perform now, and you see the benefit of doing that change, only then do the change.
I know why you are not seeing the messages, because they are sent privately. Probably it was addressed to you, not to me.
Okay,
he
but privately to whom?
Exactly. Mentioned that it's giving performance issue because of row chaining. What I want to say, even I haven't worked too much on 1201 with JSON. If I remember correctly, that this was the first version of Oracle when JSON appeared, and it was not very well implemented at that time. So I wouldn't recommend someone to use JSON in Oracle 1201.
Yeah, it's probably too early.
A little bit too early. So I wouldn't jump on it on that version.
So yes, I'm running this test now on Oracle XE, but it's it's 18 or 19. So they had a lot of time to actually go through it. And even before, you didn't have all the things that I presented. At first, there were only a subset of the things that I presented. So exactly like Mirela said, unless you're using 18 or 19, probably it's safer not to use it, but you'll have to evaluate to what are your business requirements, and if it fits, okay. If it doesn't, then and you'll just have to wait for an upgrade.
It's Pete here. I heard that about the 300 column table. I have no problems with a large number of columns. And keep in mind that row chaining is probably not as expensive as reading a CLOB or an out-of-line JSON document. I'd get one question to the person who brought it up. If the meaning of a column changes over the row series, like if column 15 is first, the meaning has an address, and in later records has a meaning of a telephone number or something, then I would hesitate, because if you have 300 columns of a varchar 4000 and you store into that whatever it is, that's a glorified spreadsheet, and that's time. Then it would be time for a JSON document maybe rather than a table. But that's just a side thought.
So yeah, it's a complex thing that needs to be analyzed to provide the right solution. It is so many things that you have to keep in mind. It's hard to say do it or not do it. So it depends on so many things. What data you have, what are your requirements, how you query it, how is it going to change, and only then someone can tell you for sure, okay, do that or don't do it. But unless I would say that evaluate it thoroughly before you decide something.
Yeah. Agree.
Okay.
Yep.
So let's not. Okay, so I already jumped over Pete in Pete slot. So thank you for attending my presentation and for the questions. And I think that now it's time for to give to give Pete the chance to speak about his part. Okay.
Thank you so much, Vlad, and I hope that we will meet sometime in person.
Sure.
In the
Why
future,
not?
we will keep in touch.
Let's hope the COVID is going to allow us to do that.
Yeah.
We will come to Cluj.
Okay.
Yeah,
so,
you have. I already sent you some, just one, but we have many places here that are very nice to see. Actually, the Apusen Mountains are very nice. If you come by bike, that's going to be amazing.
Okay.
Yeah.
Good.
Okay.
Thank you so much, Vlad.
You're welcome. Thanks, everyone.